Okay, to stay on time, we'll introduce the next speaker.
Next presentation is 151. Speaker is Dr. Yuval Ramot from University, Israel. This morning he presented a very interesting paper, but this time another topics. Title is Stable Polyamine Analogue, N1-methylspermidine, Prolongs, Anagen, and regulate human hair follicle stem cells by antioxidative, anti-inflammatory, and peripheral clock-related mechanisms.
Thank you very much. So the topic of my talk would be the effect of polyamines on the hair follicle, specifically N1-methylspermidine, isomer closure. So polyamines are very important to normal cell function. They have many different functions, not only in hair follicle cells, but in the whole body cells. They're important for differentiation, migration, angiogenesis, and many other functions. They are also serving as growth factors, and therefore, since the hair follicle is one of the most highly proliferating organs in the body, they are also important for them. Just as an example, this is an in vivo experiment where methylspermidine was applied on the back of mice, and you can see that it enhanced hair shaft elongation in Anagen. And also we know from humans that if we inhibit the ODC enzyme, which is the key enzyme for the production of polyamine, we get hair loss. This is known as flornithine or vanica. We also showed before, several years ago, that spermidine can promote human hair growth and can also modulate stem cell function. But the problem with this experiment that we used spermidine can be easily degraded either to putrescine or to spermine, and these polyamines have different functions in the cell. So therefore, we had two aims in the current study. One was to see whether the effects that we saw with spermidine were indeed specific to spermidine, and the other thing was to see what are the mechanisms by which methylspermidine exert its effect. So we used N1-methylspermidine, which has this methyl chain here, which make it a stable compound which is not degraded in the cell. We used two methods. We used the Philpott model using microdissected organ culture human scalp hair follicles and also human keratinocyte cell lines. So first we wanted to check whether we see the same effects with N1-methylspermidine like we saw before with spermidine, and we indeed saw the same effect. We got Anagen prolongation effect and also decreased apoptosis with N1-methylspermidine. We also saw the same effect on stem cell markers. We had increased keratin 15 expression in N1-methylspermidine treated hair follicles, and we also saw that N1-methylspermidine has phytoprotective effect on the hair follicles in culture. So next we wanted to know how exactly N1-methylspermidine exerts this effect. So we checked several mechanisms. First, we wanted to see whether there are anti-inflammatory effects for N1-methylspermidine. For that, we checked three inflammatory cytokines, TNF-alpha, interleukin-1 beta, and interleukin-1/6 in human keratinocytes in culture. We checked both at the mRNA and protein levels in two different time points. We first induced inflammation by adding LPS, and then we checked how much inflammation we saw with N1-methylspermidine. As you can see, in both time points, all three cytokines were decreased with the addition of N1-methylspermidine. So one effect that N1-methylspermidine has on the hair follicle is anti-inflammatory effects. Then we wanted to see whether there are also antioxidative effects for N1-methylspermidine. For that, again, we used keratinocyte cell lines, and we checked intracellular reactive oxygen species generation. And we saw that with N1-methylspermidine, there was reduced oxidative stress, which was comparable to the same effect that we see with alpha-tocopherol, which is a well-known antioxidative compound, a vitamin E derivative. Furthermore, we checked in the Philpott model the effect of N1-methylspermidine on MTCO1 expression, MTCO1 is a marker for mitochondrial activity, and we know that if we have increased mitochondrial activity, we can have also enhanced ROS production, which can lead to cell damage. And we saw both of the mRNA and protein levels that MTCO1 expression was downregulated. So additional effect of N1-methylspermidine of the hair follicle is antioxidative effect. Finally, we wanted to see whether N1-methylspermidine has effect on the intrinsic hair follicle cycle, and for that we checked period 1 protein expression. We saw at the protein level that the amount of period 1 was decreased following N1-methylspermidine treatment. That was also true at the mRNA level, and we also checked at the mRNA level the clock expression, which was downregulated as well. And we know from previous experiments from Ralph Pau's lab that if we silence period 1 and clock expression in the hair follicles, we can prolong Anagen. And that's what exactly we saw in our experiments. If we downregulate period 1 and clock, we get enhanced prolongation of Anagen prolongation. So if to summarize, we now know that N1-methylspermidine has Anagen prolonging effects, which are mediated at least by 3 different mechanisms. So to summarize, we saw that N1-methylspermidine has crucial Anagen prolonging activities in vitro, and they can also be probably effective also in vivo. Just want to emphasize that the method that we use mimic systemic application because we add N1-methylspermidine into the culture, but so this can be maybe harnessed in the future as a nutraceutical. I just want to shortly add that there are 3 different effects for N1-methylspermidine, which are very important. These are cytoprotective effect, anti-inflammatory effect, and also enhancement of stem cell markers. All these 3 effects can also maybe be used in the future as an adjunct therapy, not for primary scarring alopecia. I would like to thank Giuliani for the support in this research. I received a fellowship grant from Minerva and from the Academy of Medical Sciences, and I received a travel grant from the HRS for presenting this talk. Thank you. And I would like to thank Professor Pau from the University of Manchester and Munster for supervising this research, the people in Giuliani, specifically Dr. Barbara Marzani and Dr. Daniela Pinto, and Dr. Marta Bertolini from the University of Munster for their help, and to Professor Totogorski for his support. Thank you very much.